All right, and we're back. We're going to talk about our next structured cabling system. Um, the remainder of the topics in the chapter, I at least want to hit for familiarity's sake. You do run into these occasionally, or at least some of these, so at least you would recognize what you're seeing. But again, the predominant systems are 568. That's why we're going to cable all that in the lab. All right. Next one they mentioned is the Avaya Lucent AT&T Systemax PDS or Premise Distribution System. Very similar to the 568 system. As a matter of fact, a lot of the stuff for the 568C system comes from phone systems that were developed by AT&T, that sort of thing. So a lot of the stuff we do in the 568 standard comes from things developed by AT&T that are in this system. Multi-purpose telecommunication wiring system that can also be used for LANs. Now, what you notice here is this was designed for phone, and oh, by the way, you can use it for data. Meanwhile, the 568 was primarily designed with LANs in mind, but can also be used for phone. So slight different focus. But the AT&T system designed mainly for phone, and oh, by the way, you can use it for data. Uses unshielded twisted pair for your horizontal cabling, 4-wire, 24 gauge, 8-pin connectors, and fiber for vertical wiring between the TRs using ST connectors, older style fiber connector. Hierarchical cross connects where large pair count cables are terminating and fanned out, smaller cables out to the stations. The main component used in this is the 110 block. This is the main cross connect component for this. So as I look at this, I have the 110 block and I have the 110 connecting block, which we'll look at in just a minute. Our color codes for this basically compare to the 568B color code that we're used to with your T568 standard, your 568C standard. The color codes, as I like to say, the color codes we use in 568 standard came from stuff like this. Um, the fundamental component here is the 110 block, this guy right here. And this actually looks very similar to the stuff we see on the back of patch panels. That gets mounted to the wall, and then these connecting blocks get snapped on top for making connections. What you're seeing here is this often looks like the back of the patch panel. And then these are like metal fingers in the shape of a V that snap down over the wire. So what it ends up looking like is this. That 110 block gets mounted to the wall, and your horizontal cabling gets fed down the wall and into the back of this frame and out onto the front of this frame. And there's your white, blue, there's your wires. They're fed into this frame. Next thing that happens is you use your punch down tool to kind of force them into place. So it looks kind of like this. So there's your horizontal cabling into this frame, kind of forced into there, ready for terminations. They now take the 110 connecting block, put it into this punch down tool, and this gets pushed in on top. Now let me back up real quick. This is your 110 connecting block. This is going to get pushed down on top. These metal fingers, these metal V's, are going to get forced down over the wire, and the metal V is going to do this. As it gets forced down over the wire, the metal V is going to cut the insulation, and the metal V will now make contact with the copper wire inside. So the metal V's are going to get forced down into here, cut the insulation on this wire, and make contact with the copper wire inside. So now it will be officially terminated after these get forced down on top. They'll get terminated. Now I have our horizontal cabling runs terminated here. And you put labels on top. Now what you do is, there's the finished 110 block on the wall. Now when I want to connect that into a phone switch or data switch, if you will, I now need a patch cable to go on top of this to connect into, again, my phone switch or my data switch. So then they use, and actually here's what it kind of looks like. There's your 110 block on the wall. There's the connecting block snapped on top. Here is a yellow patch cable punched in on top. I can either punch it in with my punch down tool, or I can use, actually here it is, here's the process right here. I can take my punch down tool and punch it on top. So there's the 110 block, there's a 110 connecting block, terminate on top, and then I take my patch cable and I terminate on top of that. And then this could plug into my data switch or my phone switch, if you will. Or I can use a special patch cable like this, and this patch cable snaps in on top of the 110 block. There's my patch cable snapped in on top of the 110 block. And now that patch cable can plug into, again, data switch or phone switch. But my AT&T system is all based around this 110 block. There's the 110 block again, and this 110 connecting block that snaps in on top. One thing you will notice with all this, that's a lot of punching in. So it's not quite as flexible as the 568 system with all that punching in. The other thing you'll notice is because of all that punching in, there's a lot of wire untwist. So as you dig deeper, what you find out is with this AT&T Systemax system, because of the amount of wire untwist, this is really not suitable for modern network speeds. 100 megabits, sure. As I start getting to gig and 10 gig, there's too much wire untwist in this system to be able to support gig and 10 gig speeds. So again, this was developed for phone, could be used for data, but by modern network standards, the amount of untwist in all these terminations is too large. It does not support modern network speeds, if you will. So there, real quickly, is your AT&T premise distribution system, roughly what it looks like with a 110 and 110 connecting block. When I come back, we'll hit the next system.